interesting things happen when we put Hadoop into this infrastructure. Number one, data warehouses scare engineers. They don't really understand what's happening in there, why their queries run for so long, the various arcana of the SQL syntax. But Hadoop doesn't scare engineers at all. So our engineers just started banging away on this large data set. And so one example is, you guys might recall that Facebook did this thing called Facebook Platform. And it was reasonably popular, and we were all hailed as heroes immediately after launching. And then like 3 months later, everyone was like, wow, it's getting really annoying to get all of these invitations to the platform apps. Like, there's this huge spam problem. And so everyone said, what are we gonna do? How are we gonna fix the spam problem? And because Hadoop was already logging all of the calls from the API tier, all of the information about the application vendor themselves, all the information about the people who installed the application, we were like under a week able to put together a reputation scoring system and push it to the live site using Hadoop. And so, if you have an application yourself, I don't know what it looks like today, but it used to rank you between 1 and 7 in those buckets. And so that was all generated via the scoring system that we built on Hadoop in less than a week. And that kind of opened my eyes and said, wow, it's really handy. And so that's kind of what Roger talked about earlier about persist first, analyze later. It just so happened, because it was really cheap to store all that data, that when a problem came up where we needed it, we were able to push a solution really quickly. And so that infrastructure worked pretty well for us. I talked about where we got data from, a bunch of log files. The application databases are actually pretty tiny. If you compare the data that Facebook stores in the databases which serves a live site versus the data they store offline to analyze it, it's ridiculous. It's like 2 or 3 orders of magnitude less to serve data to the end user. So that problem to me seemed not interesting. It was this kind of like building this giganto historical data store, which sounded fun. So what's happening every day in that Hadoop cluster is you have these thousands of multi-stage processing pipelines that are running, and actually keeping track of those was kind of the hardest part of my job. And they're doing all sorts of things. They're building summaries for data which is consumed by external users. So if you have, if you ever seen insights, if you have an ad running on Facebook, if you have an application, or if you have a page on Facebook, you get all this data about how people got to that page, or all that good stuff. So that's all being calculated in Hadoop and then published back out to some MySQL servers. We also obviously had a lot of summaries for internal reporting, business intelligence that we used. A lot of the work on the ad optimization pipeline, every hour we would kind of calculate statistics about click-through and republish an update to the ad server. Experimentation platform. So if you want to figure out if a green button is better than a blue button, we had a system that allowed you to pretty quickly just deploy that and automatically do the test of significance offline. So there's all kinds of stuff. And of course, half of my group were all these machine learning statistician folks who were doing these ad hoc analyses or these long-term longitudinal studies. So they were just kind of flinging queries at this system. So I took this, I don't like to quote about while I was there, so I took this from a presentation from Ashish Thuso, who's managing the old infrastructure group that I used to run at Facebook. And so this is a recent presentation. So the largest cluster running Hive at Facebook, which is the system for data warehousing above Hadoop, is 4,800 cores and 5.5 petabytes of storage. They're adding about 4 terabytes of compressed data per day. That comes out to about 15 to 25 terabytes uncompressed per day. So that's very large. There's scanning, which is the MapReduce jobs cover 135 terabytes of compressed data per day. That's almost a petabyte of data that they're processing every day inside of Facebook. 7,500 jobs per day. And I thought the coolest thing is over 200 people per month run Hive jobs. And that's in a company of like 1,000 people. So, and over half of those people are not engineers. So there are sales planners, there are product managers running queries over terabytes and petabytes of data inside of Facebook, which was pretty empowering. So let me get to the part that I wanted to talk about, which is why people choose to use software. So I tried to be sort of introspective about this, and I thought, why did I choose to use this? And the first reason was this demonstrative effectiveness for primary workload. This tool had been used to solve a problem that looked like mine by people that I trusted. So I thought, hey, it could probably do it for me. And a corollary to that was, well, what's a unique feature of my problem? It's very large. I wanted a tool which was going to scale to 10 petabytes. And commercial vendors just didn't do that. Like literally not a single one had anything of that scale, whereas Hadoop did. So I was very intrigued by that. The the commodity nodes were great. I didn't have to buy anybody's weirdo hardware. I just got to turn to my, actually my first Hadoop cluster, I knew the ops guys pretty well. So we had a bunch of pizza boxes coming in for web servers, and I said, hey, can I get 60 of those? And they were like, yeah, we're not going to plug them in for a while anyway. So they were just servers that looked like all the servers that our operations guys worked with every day. I really wanted something that allowed access not just for our engineers, which was important, but ultimately as we built this group of data analysts and business analysts, I wanted them to be able to work with it. And Roger alluded to this earlier, but a lot of the data that we had coming in wasn't relational, and it was going to be really hard to map it to relational, including like wall post data. I didn't want to put that in a database. And Hadoop did really nicely with non-relational data. The biggest thing is I'm really lazy and wanted to disintermediate myself from every decision that I possibly could. And it turned out when you launch a new product at Facebook, the engineers don't really think about, hey, we need to instrument this for data analysis and go work with the guy who runs the data warehouse to figure out the enterprise data model for it and then set up the end reports that we want to run. They just launch the feature and then they go, hey, how come there's no data? That was, so the really nice thing about Hadoop is we just built this logging infrastructure and we built them some tools for querying the data. And then we just said, it's not my job, it's your job. If you want to get data about your new feature, just write this one line, which was log, category message, and it's going to stick it into Hadoop. And then you can come write SQL queries over it. And so that was immensely powerful in my free time. 7, cost of software, $0. Surprisingly important. We just didn't pay for anything at Facebook, and I knew that it was going to be an uphill battle. I piloted almost every up-and-coming data warehousing vendor in the space, and I was really hopeful that I could get one of them into my environment. But Facebook engineers had a big chip on their shoulder, and they were very skeptical of all the other solutions. And Hadoop was already solving our problem, and it was costing us $0. The deep commitment that I saw from Yahoo to continue development really made me comfortable betting on this. I mean, the team continues to grow over there. It's 50 to 60 people right now, and they've got like 18 recs open. So I knew that this, without me doing anything, this software was going to continue to improve. The user and developer community made me very confident that I could find new people to hire, and we frequently did hire people that we saw as being excellent on the mailing list. And lastly, the source code is open source. We like to tinker with code at Facebook, and the Apache Software Foundation owns the copyright, so it's kind of this Switzerland. And really, like, sort of the major web properties like Google, Yahoo, and Facebook have kind of settled on Apache 2.0 as their license of choice. And so it was just, it made it very easy to bring into our environment. So the community around Hadoop, as I mentioned, is the most fascinating part to me. 185 contributors were identified out of the code base about 6 to 8 months ago. So that number is probably well over 200 right now. And as I mentioned, there's a very large team at Yahoo that's continuing to grow. There's a decently sized team at Facebook that's continuing to grow. And there's a decent sized team at Cloudera that's continuing to grow. And these are all people who work on this software all day long and get paid to do it. We just held a conference in New York called Hadoop World NYC, and there were over 500 people there who actually paid a reasonably large amount of money to come to a conference in New York, which is, I thought it was like nuclear winter there. So we were very impressed. There's 3 books now out there. There's training videos. There's user groups in everywhere from Berlin to London to Tokyo to China, all across the US. It's a very international phenomenon. People teach it everywhere. The Computer Science 101 teaches MapReduce at Berkeley. So it's a lot of talent that you can hire. A lot of consultants and system integrators now. I can't tell you how many system integrators are trying to hover around people with Hadoop clusters these days. And of course, my company does the commercial training, certification, support. So let's talk a little bit about looking at the process of building software. One of the most interesting books that I've ever read is Bruno Latour's Laboratory Life, where he went in and he lived with a bunch of biologists for a couple years, and he just studied how scientists actually do science. And the whole process of kind of like this ethnographic research is to provide these thick descriptions. So you try and really dig into, record what you see and everything that people are doing. And so as I read this book, I thought, I wonder if anyone's done this for open source software or closed source software. And of course, there's a lot of interesting books. I just picked up one on kind of the development of NT, Windows NT. Some Mythical Man Month and Cathedral and the Bazaar, I think, are the most popular. And there's some academic literature on this topic. This Hurdle et al. Paper, they studied 141 Linux developers. And I'd really love to see more of this work. as folks who do startups all day long, it surprises me just kind of how much everyone just repeats the same stuff. And there are people who go around trying to pull out kind of the process of building a great company. But I wish there were more startups who talk about, here's how we ended up shipping good code. Because that's what I care about. Because ultimately, at the end of the day, most startups live and die by the code they ship. There's a lot of religion around this. I don't know how many people have gotten into flame wars about template metaprogramming, or 80 versus 120 character wide, or VI versus Emacs. But like, no one actually has empirical proof that any of these things are better. And I think that we could spend a lot more time focusing on tools for interaction while doing the coding process. I think IDEs, there's this myth that persists that developer tools are not a good business. Well, maybe it's not a myth, but I hear that from VCs all the time. And it's unfortunate because that's what a lot of us spend all day doing here, and I wish we had better tools to do it. I'm looking for a good issue tracking piece of software. I don't know, I use Jira. It's really slow. We tried out Pivotal Tracker, we tried out Rally. I mean, this is something that every single startup does, and the tools suck. So I wish we spent more time doing this. So there's actually an interesting study. So these structural conditions for success of an open source software project. And at Cloudera, we work with a guy named Doug Cutting, who I mentioned is kind of the founder of the Hadoop project. He also founded the Lucene project. He's a very, very well-known person in open source. He's actually one of the board members of the Apache Software Foundation. And so we talk to him a lot. We also have the guy who created Ganglia, which is an open source monitoring piece of software, Matt Massey, and he's done a great job building that community. And we have a guy who wrote the book on MooTools, a JavaScript framework, and he's one of the core contributors there. So we talk a lot about how do you seed an open source community and grow it to an active one. And these folks actually did an empirical study and tried to pull out some of these principles. One that I like, it's not really clearly stated here. Authority comes from competence. There's no hierarchy of reports in an open source project, and it always befuddled me to go into these companies and see these reporting hierarchies. It's so goofy. I listen to people who know what they're doing. I don't care what is in front of your name on a business card. If I believe the words coming out of your mouth, then I'll care about you. And so that's what they found in their empirical study of open source communities, which is great. Part of the reason I love open source. And particularly now in the enterprise software world, there's just so much crap which comes out of vendors from a marketing perspective. So it's great to be able to, with open source, just pull down the code and talk to people and see if they know what they're talking about. Leaders have clear responsibilities and delegate often. This is often talked about in the Python community as benevolent dictator for life. Linus does this for Linux. But it's really important to kind of have someone you go, oh, I've got a problem. Here's someone who can go resolve it in an open source community. And so, Doug's kind of been that voice for Hadoop. The code has a modular structure, so people can go off and kind of pick on a project and work on it themselves without having to think about, oh man, I'm interacting with this API with 17 different folks. So that's something to keep in mind as you build your next open source project. The parallel release policy is a nice one to think about. If you look at kind of the release policies of a lot of Linux distros like Ubuntu or Red Hat, there's kind of a stable distribution which evolves very slowly. LTS, long-term stable, is often the acronym used. And then there's an experimental one for people that want to jump on it. And we built our own distribution of Hadoop at Cloudera, and this has proven to be really nice. There's kind of two classes of customers: people who wanted to just work, and people who wanted to do everything under the sun. And so that's something to keep in mind as you launch something. Giving credit to non-source contributions like documentation is really important for the health of a product, because you get people who have the enthusiasm to contribute, but they don't have the skill necessarily. And so this is a good way to continue to grow a healthy community. And then the simple and reliable communication tools, I think we're still working on that, but mailing lists seem to be it. So it's not just about building a community faster, it's also about building software faster. And there's a lot of interesting things that happen. I watch a lot of open source communities, and these JavaScript frameworks have evolved so quickly. Everyone's kind of moving towards the same set of features in the JavaScript world, and it leads to these more and more esoteric flame wars, which are always fun. Actually, one of our guys maintains jQuery versus mootools.com. So this is, to me, this is a function of them all being BSD licensed, and you can see everyone's code. And there's a really interesting piece about, I think it's from Slate, about show source being the key innovation of the web. And I think JavaScript is kind of one of those languages. So you now have these compilers like V8, or interpreters, I'm sorry, which are evolving at a much faster rate than interpreters for other types of code. So watching what they've done well in terms of letting people just show source whenever they're running things is really nice. And I also think the web frameworks have been moving really quickly. And one thing that they do is by saying pushing idioms into project structure, I mean there's this like manage.py command that you have with Django, and there's all this magic with Rails where they attempt to do the right thing, and then you tell it if they did the wrong thing, as opposed to leaving it up to you to start from kind of tabula rasa. And so building a lot of these kind of like simple reusable components and then putting a declarative layer on top of them is pretty interesting. And there's some good research going on in the systems community, particularly at Berkeley on a project called Boom, which is the Berkeley Orders of Magnitude project for kind of declarative languages for building systems. And I'm very interested in this. And then thinking about ways to push responsibility down to the community, like what Debian does with release notes. Open source is hard. That's the summary of that slide. I do want to point out, no, that's good. Last thing is how software is adopted is interesting. So you can build a community well, you can build your code quickly, but unless you can get to that last mile and convince someone to actually pick it up and use it, there's not much you can do. So there's a lot of really interesting work happening here, and I think GitHub is probably the most well known. Olo was recently bought by /geek.net. And Launchpad, it came out of, I believe, the Canonical community. So there's a lot of work and even Microsoft has something here for Codeplex, I think, for basically, oh, I've got an open source project. Now what I need is a public issue tracker. I need a mailing list. I need a wiki. And so these things let you kind of throw that up. And so the next generation of these hopefully is going to be kind of, navigating through and pulling out reusable components. And so I find these very interesting. And I watched top stories on Reddit and Hacker News go by. And actually on our blog, we noticed that Hacker News was by far the largest traffic source. So we started actually spending more time on there. And so there's a lot of kind of communal wisdom which emerges just around these kind of news aggregators. And thinking about how can we use that for good and actually pull out true opinions from these as opposed to just people who kind of download something once and state their opinion well. And the other thing is we actually did an analysis of motivations for content production at Facebook. So while I was still there, we kind of figured out, we did some like hypothesis testing of what causes people to actually put data into the Facebook system. And there's kind of a framework for thinking about this called the social learning theory. And essentially what we came up with was homophily. So if you wanted someone to start commenting on photos, the best way to do that was to show them in their news feed stories of other people commenting on photos. And so they act like they're friends. And as a vendor now, I notice this. If you want to sell to someone in finance, all you need to do is point to them how, you look a lot like JP Morgan, and JP Morgan uses this software. And so all of a sudden they're like, man, I should probably use this software. This homophily phenomenon is very interesting, and thinking about how to kind of cook that into some of these tools. So if I had kind of a code profile on GitHub, maybe they could send me to a project which other people like me work on, things like that. And then something that I've noticed in communities that I've worked on personally is that if you reward the first approach, when someone goes to use a product, there should be good documentation that anticipates their needs. It should be easy to install and get running quickly. But then the community should also acknowledge if they send a question to the mailing list. It was always really helpful for me to send them a private message and say, oh, hey, I see you're using Hive. Very, very cool. What are you using it for? If you ever need any help, just drop me a note. And down the road, I saw. So for instance, I went and gave a presentation on Cassandra at Dig a year and a half ago. Didn't think anything of it, and then like 2 months ago, I look and see that Dig is deploying Cassandra into production, and it's like those kind of kernels of saying, really reaching out to people and taking their interest, and it's kind of like building a fire. It can be very important. So anyway, I'm actually just gonna kind of stop there, and I'll talk a little bit about where I see big data going, because that's what I was supposed to be talking about anyway. So. There's a good article on the unreasonable effectiveness of data that a bunch of guys from Google wrote. And it's completely true. So what they found is in their kind of natural language processing, they could model natural language with complex grammars and take all the research which happened over the last 30 years in linguistics and use that to do things like machine translation. But the effectiveness of those techniques was trounced by just doing simple counting over very large data sets. And so this is kind of their statement of that, which is there is actually something different about big data. It's very easy, and you'll notice this if you've been participating in the machine learning world. This trend over the last 10 years of moving away from complex algorithms and just starting to stuff lots of data down simple algorithms is turning out to be much more effective. And then there's a nice paper that the guys from Greenplum collaborated with the folks at Fox Interactive Media in Berkeley on called MAD Skills. And it talks about the evolution of data analysis at Fox Interactive Media. And MAD stands for Magnetic, Agile, and Deep. And it really does a nice job of stating this kind of next generation of data analysis, which isn't about setting up these kind of sclerotic enterprise data model data warehouses which are rigidly controlled and only useful for a small subset of the people in the organization. It's much more about being very agile, storing everything, so that's what magnetic means, and then letting people do basically as complex of analytics as they want rather than just restricting them to the straitjacket of SQL. I also think that it's really hard to find data in a large organization. I actually knew folks in Yahoo Research who did analysis on Delicious by scraping Delicious. And I was like, you guys own it. Can't you just like query the internal database? And it's really because data exists in these silos, and it's also because they didn't have software that was capable of sort of gracefully growing to the volumes that they needed. So it would be really nice if if your organizations had a big file system which is like /myco, and then underneath that was kind of the organizations, and you had tools for navigating it. And I'd love to see something like that evolve. And that's kind of how I thought of the system that we built at Facebook. And then if you're going to have the single namespace for storing your bits, having a single distributed data processing engine which runs on top of it and can be targeted via various APIs will be very handy. So in the data warehousing world, you build this big database, and then to move data from your source systems into that big database, you have this thing that's called ETL tool, extract from unload. And underneath the hood, an ETL tool has like a data flow execution engine. And underneath the hood of your database, you have a data flow execution engine. And I would always look at these and be like, these guys should really talk, like their software does the exact same stuff underneath the hood, it just has a different syntax. And so one of the nice things I felt about Hadoop is I used MapReduce both for ETL as well as data warehouse querying. And so that was kind of nice. And so having this single engine which does data flow processing and can be targeted via different kinds of syntax would be nice. And then obviously storing the single namespace of bits isn't going to be perfect for everything. So having an ability to quickly materialize data into small subsets of your data into stores which are optimized for analyzing it. So one of the big lies of the relational database world is that everyone uses a relational data model. But in reality, in data warehousing, you use the multidimensional data model. You use dimensional modeling. And then once you get your data into a dimensional model, when you want to go do rapid analysis over it, you go put it into a multidimensional model. And so these things have nothing to do with the relational data model. And there are optimized stores which can manipulate these systems. So for storing multidimensional data, there's sort of things like Hyperion and Essbase and all that good stuff. For storing dimensionally modeled data, there's obviously these big data warehouses. For storing graph data, there's graph databases. For storing key value pairs, there's hash tables. So you should have the ability to rapidly materialize data into one of these optimized stores out of your big namespace full of bits. And one thing that Roger said about ProtoViz is dead on. We actually have a graphing product inside of this Cloudera desktop thing that we build, which uses ProtoViz under the hood for visualization. Because to me, we're no longer building clients. We have a web browser, and that's it. Maybe I'm biased because I live out here, but I really think that there's so much work going into the browser as a client that if you're building a system, a client system on top of anything else, it seems like a bit of a waste of time. And really focusing on user experience when navigating through data. I was blown away at the state of, one of the folks asked after the earlier talk about what's kind of the state of the art for navigating or interacting with data. And to me, it was really low. There's a company called Tableau, which does very good stuff. There's a company called Spotfire, which was unfortunately swallowed by Tibco, I believe. They did some nice things. But really, the state of the art is bad. System's getting better over time. It always drove me crazy that I'd run queries against the database for many days and it wouldn't get better. I wanted to be sort of hello Jeff, would you like to run this query again? So one of the simple things we started doing at Facebook was just showing the last 5 queries run against a table. And you have no idea how many conversations that sparked when people saw it. And there's all kinds of things that you can do like that to get better over time. And I wish people actually use the workload information that, I'm telling my data so much about it that I wish it learned from that. Another thing is the cloning and sharing activity. I did something like this, and so giving someone, so we built an internal reporting interface at Facebook, and we gave people the ability to just say, clone this report, and then edit it. So people would see a report they liked that was generating a graph, and they'd say, I wish I could see this for my data. So they just hit clone, and then they just changed like the table names, and boom, they were going. So more facilities for doing things like that, I think, is kind of in the future of data processing. And then lastly, I think a big single global metadata store, which spans the collection, storage, analysis, and reporting system. So one thing that we saw often at Facebook was there's a big multi-stage collection process which happens to kind of shape the data in a way that's needed for reporting. And the report wouldn't be there one morning, and someone would go like, oh, why is this broken? And we'd have to go investigate. And if the metadata about your data collection is stored separately from the metadata of your reporting tier, then performing this kind of surgery to knit them together was painful. So we ultimately just said, heck with it. Like, instead of just storing like schema data inside of our database and collection data inside of our ETL engine and reporting data inside of our BI tool, we just threw that all into one system. And so we had the ability to display on the screen when you're looking at a report, you could see when this report was last refreshed, and you could see the state of the current collection framework. So once again, I'm very lazy. It disintermediated us, and we didn't have to talk to people anymore. And having this global metadata store, I think, is going to be, and this is common in science domains, both workflow sharing and metadata stores. I see a lot in the scientific data management arena, but not a lot in the web data management arena. And then the last one is kind of version control for data sets, which I think is going to be fun, but very far off. So anyway, and state of the art, I did want to throw in a little bit of a plug for a product that we build called Cloudera Desktop. It's very, very interesting. It basically builds a desktop environment inside of a web browser. There's a lot of fun open source JavaScript under the hood to do this. And as I mentioned, we've recently integrated ProtoViz into this framework to allow you to graph arbitrary CSV files. And we're continuing to iterate this, and there's a small team inside of Cloudera. And so if you just go to cloudera.com/desktop, you can check it out. This is a nice way to interact with Hadoop. So that's all I got.
One question. Jeff, that was fascinating. Thanks. So being a startup crowd, a lot of us are probably sitting here thinking we would be really, really lucky, and then also we would call ourselves smart, if we were big enough to need a lot of the techniques that you were talking about tonight. Mm-hmm. So my question is, like looking back on your early experience, when is the right time for us to invest in this kind of thing?
That's a good question. So the question was, when is the right time to invest in large-scale data management technologies? I would say only when the things that you're using already are breaking. So you've got other things to do, right? Unless you're building a data analysis company, or a company which is building like marketing analytics or something like that. Like, make sure you're just building and pushing product. I would say if there's anything that I would have moved up in terms of when we built it, it would have been like an A/B testing framework, the experimentation platform I talked about. I think we underinvested in that, and we overinvested in the ability to collect a lot of data and do complex analytics over it. So just having the ability to perform tests of significance over small data sets. And I would say just log everything. Like logging turned out to be, there's kind of a difference between like state and history. And like relational databases are good at state, and they're just terrible at history. So just logging data to like a file system, like gzipping it and sticking it in an archive directory, like you're going to be glad you had it later. So I'll give one example, which is Facebook, after we let anybody sign up, just went like crazy in Canada. And we were like, whoa, what's going on in Canada? Norway too. And we didn't really know, we didn't have any tools to analyze the data at the time. We just kind of observed it. But since we logged everything, we went back and like 2 years later did a big analysis of like why those networks grew. And we got a lot of really interesting information. So I would say just kind of like, start simple, use the tools you're comfortable with, and wait for them to break. Move up the A/B testing and experimentation platform stuff before starting with like complex data warehousing. And then just log everything and gzip it away. You'll probably want to use it later.
All right, thank you.